Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Sari bin Alias, and today I'm going to present my final year project entitled Density Distribution in Multi-Layer Iron Powder Compact. So, multi-layer of powder compact is a new developing method in the powder metallurgy, the study of densification on the porous surface of cross-section single, bilayer and tri-layer iron powder compact was covered in this work. For single layer and bilayer, both manipulated layer consisted of similar mechanical properties of powder with a mass of 10 gram applied and compact under specific force magnitude in a lubricated dye condition resultant thickness of 10 mm sample. While for the tri-layer different mass of powder for each layer was used for compacting different sample, producing 10 mm, 13 mm, and 15 mm height to observe the effect of height to diameter ratio of multi-layer iron powder compact. A sample of single layer was prepared with a compaction load 95 kN, while bilayer sample with load with 95 Newton on upper layer and 30 kilonewton to the lower layer. Tri-layer sample was prepared with 95 kilonewton load applied on the upper layer, 30 kilonewton load applied to the middle and lower layer of iron. The cross-section of all sample in 3 different regions, which are top, middle and bottom region, then were observed thoroughly using an optical microscope. And for the methodology, it start with by obtain the properties of the powder that we want use, and after the powder then the compaction using the uniaxial compaction method, and then this the compact powder are soaked vertically in the mixture of epoxy, and we do the grinding and polishing until it become half to observe the cross-sectional of the sample. The cross-section of the sample will observe using an optical microscope, and after that we use MATLAB to change the image that we get from the optical microscope into the binary image, and then we use that plot and that plot program and to obtain a rectangular grid that will for the sample cross-sectional, and then we use the MATLAB again to obtain an image of relative density distribution of the sample. So the objective of this project is to first to determine the density distribution in iron powder compact using metallography technique. And the second is to analyze the effect of bilayer and tri-layer compaction on density distribution of iron powder compact. And the objective is to evaluate the effect of height to diameter ratio on the density distribution of tri-layer iron powder compact. And for the research and discussion, it could observe that sample A is the single layer, sample B is the bilayer, and sample C, D, and E is the tri-layer. Sample C, D, and E are the layer that different in height because the mass of powder used for this sample C, D, and E are different. And it could be observed that tri-layer sample, which is sample C, has the lowest our relative density if we compare with sample A and sample B. This is because of the repetitive compaction. We do the 3 times compaction that tended to reduce the effect of the lubricant that adhered to the die wall. And the sample C is also have more uniform density distribution compared to single layer and bilayer. This because the density relative of the sample C does not have significant difference from the first to the third layer. You can see for the image for the sample C. This shows that the compaction is bound to the powder top layer. The bottom part of the previous compact layer acted as extension of the bottom tooling. So there is no distinction between the layer. The thick layer close to the bottom punch of the powder interface was preserved during the following layer compaction. And we can also observe that sample A has higher strength mainly at the barrier layer compared to bilayer and trilayer sample. It also could be discovered that the minimum relative density of our sample is located at the bottom layer. This because the lowest layer of surface provides the largest mechanical interlocking or nesting for the powder particle from the upper layer to fill the bottom region. That means the first layer has been compacted 3 times compared to the middle region, second layer and top region, third layer that has been compacted 1 and 2 times respectively. As the load was reduced further, the central relative density decreased. And for the sample C, sample D and E, both these samples are trilayer that differ in height to observe the effect of height to density ratio. And it could be observed that the maximum relative density of sample C, D, and E drop as the height of the sample increase, especially at the middle region. This could explain by the constant compaction load that was applied for each layer, causing the load received not to be same due to increase in height. Roughly, all the trilayer have the highest relative density at the top and middle region, and the maximum relative density is located at the middle region of the sample. But sample C have the highest maximum relative density at this region due to better particle arrangement between the second layer and third layer. It also could be observed that the most porosity is explained by sample E. This was represented by the dispersion of the near similar size of porosity across its cross-sectional surface at the bottom layer. This is because of its height. Height can cause the loss distance between the punch and the powder. And for the conclusion of this project is the metallography technique employing a convenient approach to determine relative density distribution of higher compact sample. This technique required to be used with extreme caution to produce a high quality microscopic pictures. The second conclusion is density distribution of the trilayer significantly different from the bilayer and single layer, where the trilayer possess the highest magnitude of porosity. And the third conclusion is the effect of height to diameter ratio, HD ratio of multilayer and compact. Density distribution of cylindrical compact is the smaller the HD, the height to diameter ratio value, the more homogeneous the density distribution. So the application of this project is the new method which applying the multi-layer compact powder could create new part with various properties, since this method could control the porosity with the suitable parameter. Many industries such as automotive could benefit from this development and technology. With more research and advancement in powder metallurgy, more achievement and new method could be explored. Okay, that's all. Thank you for listening.